Hello and welcome to a LØRN chat. My name is Silvija and my guest today is Pierluigi Salvo Rossi, who's a professor at the Norwegian Technical University in Trondheim. Welcome.
Thank you. Hello to everyone and thanks for inviting me. Very nice to meet you here.
Very nice having you here, Pierluigi. And I see that we're going to talk both about your research, but also probably about your hobbies and the guitar.
Okay.
Let's see where it takes us. I'm just going to say a few words about the series so people know what they're listening to. So basically, this chat belongs to a series we have defined as Applied AI. And the idea is to give people examples of where machine learning, data, artificial intelligence, and things like IoT can be brought into their everyday life and everyday work. Too many people still think that this is a little scary and a little distant, and we want to give them lots of examples with a tiny bit of theoretical explanation around them. Sound good?
Yeah, sounds good.
Okay, cool. So then we'll start, and my question is always basically, who are you and what has made you so?
Yes, well, that's a strange question, but I consider myself like a person that is somehow involved in technology development, mostly doing research. I've been interested in research since when I was at university as a student. Before that, I mean, as a child, as a teenager, I was quite curious with many things, including music. As you was mentioning, I was playing the guitar. But then since I started university and engineering, I became more focused towards this domain that is called signal processing, that somehow is related to AI. And I've been focusing more and more on research because I got really excited with this kind of work. And then I've been working most of my life in academia, between Italy and Norway, with some visit also in Sweden and US. And a couple of years of experience also in the industrial private sector. I've been a data scientist for a couple of years with Kongsberg Group. But still mostly doing research, applied research work. So maybe this is me from a slightly professional view.
So I have 3 questions. One is, what do you do with the guitar? The other one is, I see that you were interested in math, philosophy, and literature before you became a very pragmatic engineer. So I'd like to hear you on that. And then I'd like to hear you about why Norway.
Yeah. Well, first, guitar, I'm saying nothing professional. It was just a hobby at school. I was playing in a band with friends, as many people are doing. I'm really like hard rock and heavy metal music. So this has been still what I listen to now when I'm working. Has been listening to this when I was studying. Is kind of my constant soundtrack in my activities. And
give me 2 examples. What do you listen to now?
Yeah, for instance, still music from the 80s mostly. Like it can be like Iron Maiden, very popular, or like more Los Angeles kind of hard rock style. And yes, so and then I was just playing with friends in some bands, this kind of garage bands. Enjoying this kind of hobbies, but never became serious. I mean, of course, I didn't choose to go for a professional music study and these things. As I was saying, I mean, I was also interested in literature and philosophy in high school. This was something that was really curious about. And also math. I've been always fascinated with math and in general, abstract thinking. This is something that typically I prefer. But for practical reason, then I decided to go to engineering just for, assuming that it would have given me better job opportunities. And then I discovered signal processing into this engineering. I enrolled in the telecommunication engineering program. And then when I discovered signal processing, that is basically applied math and applied statistics. It's very abstract, but it also has a lot of implication in the practical world. Then I really fell in love with this topic. And then I've been mostly working with that all my time. And so this was what's the other question? Then
Norway.
Norway. Why Norway?
You came to Norway for the weather or the lovely Norwegian ladies?
Yeah, well, I will say that I don't mind. I really like also the Norwegian weather. So although this might be uncommon, but Norway was, as many things in other topics in my life, it's been a little bit maybe by chance, because I remember the first time it was with my girlfriend, that now is my wife, many years ago. We were looking for summer holidays planning in a travel agency, and we went there and we were planning. We wanted to visit Stockholm and Helsinki. But that year, there was a big sports event. I don't remember exactly, in Helsinki. So everything was full booked. And then looking at the brochures and these things, we looked at a picture of Bergen. And my wife, she said, oh, that's the kind of place I want to visit. So we arranged moving from Stockholm, Helsinki to visit Oslo, Bergen, the fjords, and this trip on the fjords. And we went also to Flåmsbane, this old railway. So that was just our summers, and that kind of holiday basically had a huge impact on our life, because I was almost finishing my PhD studies at the time, and so looking for postdoc, I was considering moving abroad. And as a child, I've always had the dream to finish my studies and then move to US. But then after that, my wife really enjoyed Norway and these sceneries. And of course, I mean, Scandinavia is quite popular for high quality of life. So we thought, okay, why don't we apply for a postdoc position in Norway? And then I got a position at NTNU as a postdoc, and it was 2006 at that time. So we came here in Trondheim for a couple of years. And after that, I went back to Italy because I got a position there in academia in Italy, but we have been still keeping contact with the NTNU and visiting for project and collaboration. And after a while, we decided, well, we really miss Norway and we really like the way we were living here in Trondheim, especially Trondheim. So we decided to change again our life and move back to Trondheim. And why Norway? I would say the main thing I would say is it's a very nice quality of life. I mean, this is not just thing that you read in the ranking and these things. I mean, you really, in my opinion, you really feel it when you're living here. It's just that the ordinary life is very, very joyful, I would say. So we really, and of course now with children, this is even more, especially in Trondheim, that we consider a very children-friendly city. So it's something that we will never change, I guess.
Yeah, no, I agree. I'm originally from Yugoslavia and have lived in England and US and France in different places. But I at the moment where I had to make a decision on, where my kid's going to grow up, I thought that there is no better system in the world than in Norway.
Yeah.
And it I don't think people necessarily appreciate, if they've lived all their life in Norway, how well the system actually works.
Yeah, exactly. I mean, this is, as you said, I mean, this is exactly the place where we want to grow our children. So I would say this is the main motivation.
Yeah. Yeah. So a little ad for talents coming to Norway. I think both you and I believe that there is space for more.
Yeah.
Yeah. Cool. But Pierluigi, so tell us a few words about what does signal processing means. What picture should people have in their heads when they listen to you talk about signal processing?
Yeah, more specifically, I work mainly with a branch of signal processing that is related to data fusion and statistical signal processing. And this is basically combining information from different sources that can be sensors or can be other kind of source of information, combine this information to take reliable decisions. So this is basically, if I should summarize in one sentence what I'm doing, this will be the sentence. And to be a little bit concrete in a simple way, so I was mentioning you before this silly example that I typically use in the first lecture in my course, in which I consider this silly game in which, let's assume that we have like two jars in a different room that are filled with colored marbles that can be red or blue. And then we ask a child to pick one marble from one of these two jars that we can call the alpha, beta, or whatever, these two names. He picks one marble from this jar, comes to our room and shows this marble. And then we have to guess which one was the jar that is selected for picking the marble, just by seeing this one. So this is a sort of inference problem in which we have an observation of something that is related to something else that we don't have direct access, and then we have to make a guess. How, based on knowledge, how do we do reliable guess? This is basically my job, and this has implication in AI, in IoT, and in all the kind of smart devices that are transforming our society into a smart society, if you want.
So if I now go from jars and red and blue balls to an oil platform, and an oil platform might have some wave sensors, it might have some location sensors to know whether it's horizontal or at an angle. It might have some wind sensors. It might have some temperature sensors. And it could read all of these sensors and from that try to infer whether it's getting too much at an angle.
Yeah, for instance, I mean, this kind of processing may be targeting like optimization in the extraction and the use of resources. For instance, one of the projects that we are currently working is, for instance, for improving and leakage detection. For instance, you have these sensors that are acoustic sensors that are detecting if there could be a leakage. And then by processing all this information, of course, when you have sensors that are detecting some events, sensors are not perfect. So their information might be wrong, simply because there is something failing or there is a false alarm, to be more technical. And of course, so the point is how you combine all this information to make safer decisions. And this could be, for instance, designing safer equipment that will reduce the number of useless maintenance, for instance, and then will detect exactly when the problems are happening.
So one of the interesting things here is if we go back to industrial problems, or let's go back to the platform. So they have these cables at the bottom of the sea that transfer gas or oil, and very bad idea to have a leakage there. So to try to again put a picture in our heads, we could measure the pressure in these cables. We could maybe even do you measure the quality of the water? Could you discover that there is some oil coming out? Is it chemical or is it?
Yeah, I mean,
what kind of sensors?
What we are doing is mostly a more like theoretical thing. I mean, like my group, we are not designing the sensors. So assuming that there could be chemical sensors or temperature sensors, acoustic sensor, or other kind of sensor that people that are mostly working on sensor development is more on the electronics. That's expertise to design. So given these sensors, they will then send something and collect information. What I'm doing with my research group is how to process this information in a more effective way, so that actually when they are telling an alarm, can you trust or not? Is it really an alarm or something else, for instance? Or can I detect in advance that an alarm will coming because now is something strange going on from this measurement, so I can expect that there is an anomaly. This is anomaly behavior that could lead to a problem. So this is the kind of things that I'm working. So processing data from, let's say, system that someone else has been designing.
So it's almost like you are creating the formula in a way that, given that we have these kinds of sensors, I can then conclude or in real time understand what's happening with the location or with the quality of service, and given this reality of sensors becoming cheaper and very, very much more available than just 3 years ago. I mean, now we can buy off-the-shelf sensors from China if we wish, that were, very recently just for defense sector. So now you can actually create systems that could potentially be a little lab on a chip that would control, things that have to do with, let's say, my blood or my urine or some health material from my body, or they could be used in industrial production, or they could be used for security in a city.
Yeah. I mean, this dimension is very relevant now because this is partially the explanation of why machine learning and in general this AI is receiving all this emphasis now. Because let's say, as from my perspective, I'm mostly used to combine information. And this is, as you were saying, I mean, if we want to say in a more technical way, this is basically applying statistics to combine this information in a reliable way. Okay. Now this information,
you're making statistical functions in a way.
Exactly. And the nice thing, this is happening really in everything. Even in our discussion now, this real-time discussion is happening because the device are able to make inference on what I'm saying. What I'm saying is translated into a signal, electrical signal that is covered, and then you are receiving this signal, and this, based on this signal, this is transformed back into a voice based on some statistical guess of the device that are just applying statistics in making this. And actually, as you can see, this works because we are able to discuss real time, even if we are far away, right?
So, and I have to stop you. I have to stop you. Sorry. I have to stop you, and I'm going to just be silly for a moment. So in another example where we can see this while you and I talk, for those who are actually looking at the video. So Pierluigi is Italian, and he uses his hands a lot. And with his hands, he can create a light show behind him. I don't know if you can see it on your own camera. I see it's very sunny in your room. But as you move your hands, the system is trying to optimize the light balance. And sometimes when you have your hands in front of the camera, the picture will go very light or very dark. And
maybe I should...
No, you're looking perfect, and I actually am enjoying the effect. But I just wanted people to realize that that's another example of what you just were saying.
And yes, so I was saying then it's this availability of sensors. This is nice because now a lot of information that we are gathering is actually coming, as you were saying, from the availability of a lot of sensors that are becoming cheap. We have a lot of devices that are deployed in our environments, and we have a lot of devices that are connected because now we have everything that is connected. Everything is becoming a sensor speaking, a smart device. So we have a huge amount of data that are collected from the real world that can process. And actually now the processing capabilities is also becoming much cheap. And now with just a few $100s, we can afford what 10 years ago was, or 20 years ago was the largest supercomputer in the world. Now this can be, everyone can afford with a few $100s and buying a similar equipment. So even the processing capabilities now have been increased a lot. So this is why now there is a lot of emphasis. I mean, it's not surprising that this AI and data-driven methodologies now are really seeing a nice summer, if you want. They are flourishing because now we have all this data available. We have the capability to storage, and then we have capability to process all this data. So this partly explains why AI now has become so popular and so relevant, because actually we have the possibility to exploit what data has to offer.
So lots of data because of all of these sensors. And actually, I think that we have only seen the first 5 minutes of this summer in a way, because I don't think we realize that we are going to be wearing many, many more sensors in the near future. And that our houses are, we've been talking about smart houses, but it's only recently that we've started putting these sensors inside them. Lots of computational power and lots of network, right?
Yeah. And I guess, yes, you're right. I mean, there will still be a lot of things to come, although I guess there could be maybe a sort of, again, of misalignment between what is really coming and what is maybe the expectation of general people and common people. Like I typically use an example that was made if you go back to some decades ago when there was a lot of expectation about this, if you want to call it robotic revolutions, and a lot of, like in the fiction and in the general people were expecting these humanoid robots. What came out from them was mostly like washing machine and all this kind of equipments that are now popular in our home. That is kind of absolutely useful and wonderful, but it's totally different from these humanoid robots that you could see in the fictions and these kind of things. So there is a kind of misalignment of what is really happening and what is the fiction, science fiction, and expectation around this. So I guess something similar might happen with this AI, in which maybe the expectation are more close to this, I don't know, general AI that will control maybe our lives and something. Well, what will come, it's really extremely useful things that are much more practical and restricted to specific application. At least I would expect this in the next years, in the short term.
I 100% agree with you. So basically, I'm a bit sick of the general AI discussion and the ethics of it and so on, because what I see is especially in China perhaps, is this race to apply AI and apply it to health, to climate, to production, to transportation, to many of the practical areas. And that said, I think that we humans, we are a really bizarre creature. We can create technology that creates opportunities that are far beyond our current understanding. And I think there is always this lag of, between the potential and the real effect of technology. And I think that whoever manages to exploit that gap will also have enormously much to gain, which is why your research is super, super important. Where is this relevant? And again, that said, I don't think we should underestimate the effect that, let's say, washing machines and fridges have had on our lives, or even on the liberation of women. So they end up doing something for us that we didn't anticipate, and it's in the management of these anticipations that I think the magic lies.
Yes, exactly. And this, in my opinion, is totally exciting, even if it's something completely different from maybe what was the expectation. So, and if I may link to, it's nice that you said, you are a little bit sick of this kind of skepticism or criticism, on the general. And another thing that I totally agree with you, and another strange thing that you might also be a little bit sick is this constant criticism, like AI is a black box and something we cannot trust, we cannot apply. This is also another strange things to me that I really, maybe I shouldn't say sick of listening this, but still, I think it's not really a fair use of a fair criticism of AI when these things, because if you compare, if you want to take this literally black box, for instance, we move this to some other, moving from machines and AI to humans. And for instance, when we are as a patient, as a user in an hospital or in an airplane, we totally trust the pilot, we totally trust the doctor, although for us that's a total black box. We have no idea what he's doing, why he's doing, but we trust. But we trust the training system that has led that person to be there. So because he has been undergoing some training, school and other university and other things. So we trust the training. So if that person is there, we trust the training. And even if I have no idea what he's doing and why he's doing, I trust the old system. And this is the same thing. We should. The problem is not really that the machines is black box or not. So it's just a question. Those machines should be able to work and explain what they're doing, and also maybe this what is called explainable AI is a relevant topic. And finally, some topic that when I first listened to that, I was thinking, it doesn't sound very interesting. But actually, after a while, I understood, well, this is totally something necessary, because of course, in order to have this trust in the system, we need to understand not only how we need to trust the training process of that machine, we need to understand why this machine is taking decision. For instance, if we have two doctors that are not agreeing on something, they will be able to discuss, I'm telling this because of that. This other guy is telling this because of something else, and then explaining their motivation, they are possibly able to converge. So we have to provide the machine not only to take decision, but also to explain why they have taken this decision, in order that there could be a discussion maybe with a human in case of conflict. And also another relevant thing is assessing their level of confidence. Taking a decision and then assessing, I'm telling this is maybe the best way, but I'm totally confident, or this is the best way to do, but this is an area that I'm not totally confident. So maybe some other discussion or some other information is needed. So explainable AI and assessment of confidence, of uncertainty, I guess, are two crucial research topics that hopefully will, let's say, remove this black box criticism that sometimes, in my opinion, is used in a too shallow way.
I completely agree. I think it's so interesting, when they made the self-driving car and, the few accidents that they actually had. And so many people use them as, the proof that this technology is not ready. And we are not comparing the accident numbers at all to the, to what humans do. And humans are the ultimate black box. I just finished a book on consciousness. It's super interesting for a guy like you. I'm going to send you the reference, but very interesting model that could be mechanized, actually. But I'm thinking when it comes to this argument that, we don't know, we can't explain exactly why the AI judge decided this or that, so unless we can have it 110% explainable, we can't trust it. I think what we need to understand is what are the principles that are baked into the learning algorithm, as you say, also as for the learning of the people. And then I think we need to stop using alternative excuses like privacy or like explainability as or our lack of understanding of the ethics of this thing as innovation breaks, because I think that many of these things we learn by applying and thinking very fast, learning very fast.
I'm also I have a similar attitude. I'm typically the person that likes to jump into something and then, as I say, maybe underestimating the risk and then discover, but now we have to go for that.
And then you have to learn very fast, and you have to fix very fast. But I think at the moment, we don't have enough of perspective to anticipate all the future problems. But the way that we are working at the moment is, at least legally and politically, is let's wait until we figured out all the risks and problems. And I think we're losing
this will create problems, of course, because if this gap between technology and then the legislation is increasing, this will eventually create even more problems, most likely, because I see necessary that all the legislation and the rest should be trying to be as fast as possible as together with technology, because just stopping or creating barriers is not working, will not work. And then as long as this gap will be increasing, I guess I just see this as a potential for new problems, not a solution.
Yeah. So my position on that is that creating barriers and waiting is only helping the others who are not waiting. And unless you're in the game now, 10 years down the line, you will have even less influence over some sort of an end game. And same thing with the bias in data. So, you said your sensors are not perfect. Well, if we humans as creators of data, are the main source of data in, previous employment history or previous legal case summaries, etc. We are not perfect either. So, when people say that, well, be careful because the data is biased, towards men rather than women or something. Well, I guess our job is to recalibrate it now for the future rather than say it's not a usable data.
Yeah, totally agree.
So my question to you is then, how do you apply your work in practice? Do people come to you and say, I need a system and help me think about how to solve it? Or do you say that, well, now this is possible, so does anybody want to try this? Or how can people get involved with your kind of work?
Yes, well, I can say that maybe both things are possible, but some years ago, I will say that it's mostly I was working on theoretical aspects of this algorithm design, and then I was looking for collaboration for a possible application to apply these things that I was working on. Then since now I came back to NTNU now in 2019 for the third time. So I've been moving in and out and NTNU many times. And then after this experience as a data scientist with Kongsberg Group. And in Kongsberg Group, I've been mostly working on projects that are related to energy and maritime domain. And when back to NTNU, I've been trying to gain from that experience and working mostly in this domain. So now I've been maybe just for lucky coincidence or something, but this is more the other way that I have a lot of colleagues or people from other departments that are just calling me and then trying to, well, we have these problems. Can you help us in designing new algorithms that are solving problems and in this domain? So that's why I have now a lot of collaboration in this still energy domain, in the maritime domain, and also moving a little bit towards also the civil engineering and construction building recently I've been establishing some collaboration in which, again, you can imagine how this sensor data processing can be very useful in also construction building for real-time monitoring. So every time there is something that makes sense to have a real-time monitoring for anomalies, so preventing problems, typically my expertise could be useful, let's say.
Yeah. So if we just take a couple of concrete examples, in maritime, it could be something that has to do with autonomous ships.
Yes.
And
for instance,
navigation.
autonomous navigation, you can imagine how it's relevant to understand if there are objects and other things, and then to help having, let's say, what I'm doing is supporting what is called situational awareness, so that the ships has to have an understanding of what is the surrounding environments to take proper decision where to navigate, where to stop, and this kind of thing. So there is identification of objects and other dangers.
Yeah. And it has to read camera data, but it can also read current data, what's the right English word?
Yeah.
Sea current data.
Yeah, it could be that. It could be camera, LiDAR, or radar data. This is typically what we are using now in this. I'm involved in one of the Center of Excellence at NTNU on autonomous shipping, that I think is a very relevant. I mean, there are a lot of activities happening in Trondheim related to autonomous ships. And I think this is a very exciting topic, and is something in which Norway could easily be worldwide leading. So this is one of the topics that I consider very strategic for Norway.
And in buildings, it could be, for example, sensors that read the temperature and find out what sudden temperature rises or falls, or basically rooms that never get properly used because the temperature never rises. Yeah,
or for instance, I mean, another project that we are developing is not started yet, but we are proposing is also, for instance, using satellite data for monitoring ground motion, and this could help in preventing landslides and these kind of events.
What kind of sensors are that? You would basically take pictures from satellites, and you would be able to see if there is a movement of things that shouldn't be moving.
Yeah, this kind of things. Yes. So as I said, I mean, I really don't care about. I'm not don't care. I mean, it's not. I'm not involved in the sensor designing. But once we have the understanding of what is the sensor measuring, then based on the measurements, we develop algorithms that are combining this information, these measurements, to take decisions or make predictions.
So a very expensive part of these projects for the customers until recently was actually putting the sensors in the system. Is there some sort of standardization going on there? And can you just say, well, if you have a sensor that can give me this kind of data, I really don't mind what sensor it is, and it's easier for them to get going now?
Well, this is a critical part. I would say maybe the most critical. So it's very nice that you pointed this question, this point in the discussion, because maybe this is the most critical part in a project. But this is also a part in the project in which the expertise from the people that are domain expert is really necessary, because, and this I also would like to emphasize this part, because sometimes there is a feeling in which like data science could be a sort of threatening expertise of people in their specific domain, like that could be in medical domain or in the geoscience or something else. But this is absolutely not true. I mean, listening to people that says, okay, you just provide me the data and I will give you the answers. This is 90% of the time just will result in nonsense results or in something that is already known from ages in that domain. So this is not the way to proceed. Having interaction with domain expertise and data scientists that are working together in an iterative way is really necessary to have a successful project. And the first part is just this data collection, and you were saying. So you need data that are realistic, that are reliable, meaning that are not biased, that are meaningful, and that are meaningful in the say that they represent, possibly without bias and without other strange artifacts, the scenario that you are going to have in operation. And there is no way out of involving expertise from that domain in building a proper data set that is meaningful, first of all. And then, of course, even understanding what is the relation and what are the artifacts and what are the things that you can exploit. For instance, I mean, if I know that temperature and pressure in these things are particularly linked, or in another scenario, they are not and they can be neglected, this is an information that will save me a lot of computation in my approach. And this is something that is typically coming from domain expertise. So we typically, as data scientists, will rely a lot on the expertise from the people working in the domain. And finally, sometimes it's just not possible to have enough data. You can think of, for instance, in the underwater domain, it's not easy to place sensors underwater and collect a lot of data in different situations that are realistic. So you have to rely on simulations. And typically simulations and the software for simulation are developed by people, again, that are expert in that domain. I don't know, they can have expertise in thermodynamics if this is a process engineering, or they can have expertise in maritime engineering if it's or something else. So you really need this interaction with people from that domain. So data science is not threatening the expertise in any domain. It's just enlarging the possibilities. It's basically, the main effect is just providing this group of, instead of having much more resources and 10 times more experts working full-time on the topic, so enabling their power. This is basically what is data science, but it's not replacing anyone.
It is, in a way, giving them extra horsepower for the manual processes that they had to do before. And I'm thinking of an example before AI. We had this, we had the mobile and the internet revolution, but even before that, we had the spreadsheet revolution. And I remember when Excel-like tools came up, and then people were saying, now there's no more work for accountants because, the system will do everything for you. Yeah. And yet they became more useful and more necessary in larger numbers than ever before because their subject evolved. It became much more complex. And so you needed people who know the legalities of accounting, and then you had these advanced tools that would help them develop and deliver. And I think something similar is happening in health, in engineering, in many, many industries, but these are necessary tools for tomorrow. Yes. You can't say, I don't want to use them.
Exactly. And these tools, as you say, it's important. I mean, this will not replace the need of people. Will just make that the people will need to provide something different. Maybe it's at a higher level or in more complex, but you will still need people like with legal expertise or with medical expertise or with thermodynamic expertise or whatever. So there will be no replacement of this kind of expertise. It's just that their task will change. So you need people that are used to be able to change what is their task. And this is why I stress that what is important, the most important thing to learn is not a specific topic or something, but the best thing to invest is the capability to learn new things fast and deep. This is what will always be needed, because now it's even more, we cannot be expected to be doing the same thing for all our working life, similar task, but we need to adapt to new way of working and new things and not new expertise, but new way to applying our expertise. So the ability to learn new things will be crucial even more than before.
So this is music in my ears, of course, given what the mission of LØRN is, and it's actually to make people want to learn new stuff and also kind of have the courage to say that, what you're doing, Pierluigi, is not just for students at NTNU. I think, as you said, there are many, many people both in Kongsberg, but also in many other engineering, building, shipping, energy companies that will need to start thinking in these terms. And then my question is, how do they get started? I guess it's through projects that we have to learn. You recommend a book called Statistical Signal Processing, but the little I remember from that kind of literature, and you have the estimation theory and detection theory by Kay. I mean, it's not exactly kind of summer poolside reading, right?
Yeah, that's right. But I mean, I guess now really, I mean, if someone is curious about things, you are really overwhelmed with a lot of different opportunities at different level. You can focus on books, old classical style. You can look at lectures on the web. You have seminars, and then you have even classes online from MIT that you can find on YouTube that are. So there are really a lot of, I guess each one can find the proper way that feels more suitable for each level of entrance and find the proper way. But I guess having this curiosity to learn more and to be exposed to this new domain in which there will be this interaction between, let's say, classical topics and collaborating with data science is really something worth investing, in my opinion. Because I cannot see that this will, I cannot imagine any sector that will not be affected by this kind of interaction of data science together with that specific topic.
Very interesting. Yeah, I asked you if you have a quote that you could leave with our listeners as a little parting gift, and
yeah, I was selecting one this by Woody Allen, that is confidence is what you have before you understand the problem. And this is just, I like this because it's just somehow I'm like crazy in this perspective. I think people should jump with enthusiasm into a new thing, even if they might seem scary at the beginning once you've jumped. But once you jump, well, you need to swim, but then you will enjoy swimming. Because any kind of new challenge will bring you some kind of adrenaline shock maybe, but you will find a lot of things to enjoy. And at least for me, when I'm learning new things, I'm always enjoying. So what I'm really, maybe if I go back to your first question, how you will define yourself, maybe I like to feel as a student all my life. I always am looking for new things to learn. Having this feeling of being as a student that I'm learning something is maybe something that I'm really looking in every aspect and day of my life. So the feeling of being a student, this is something that, in my opinion, is very nice, because this is just the willing to learn something new.
I have this vision both for myself and for LØRN, to be honest, mix, match, and never stop when it comes to new knowledge. And I think you also mentioned at some point that you really like reading classical books as well. I turned 50 about a year ago, and I last 2-3 years I've started rereading and reading for the first time some of the classics. And I think that being able to do that and at the same time do something that's more mathematical or business, or it's such a good therapy actually for your brain that I think we all should do more of that.
Yeah, and of course, like in general, diversity is usually always bringing some positive aspects in everything. So I really believe this also in a small sense. Even when I'm focusing on my little research area and world, I typically prefer to have at least 2 different projects that are different at the same time. Because if you just focus on one thing in your life, this sometimes you just get bored, or sometimes you just get stuck with something. And having the opportunity to just have a break and move to something else, and then going back, then you will look at that with new eye, and things typically will proceed faster and even better. So, and this is in general, this is just now in my personal attitude to research, but I guess you can have a lot of diversity examples in every aspect of life, personal, in research groups, and in other activities. And I cannot see any real bad side, apart from, of course, you need to be able to manage a little bit more complexity when you are including diversity. But I guess the benefit will also much more than this little overhead, that is always good to increase the level of diversity in any kind of dimension in your aspect of life.
And that's a good statistician speaking, I guess, as well. Pierluigi, thank you so much for joining us here in this LØRN chat and for teaching us about statistical signal processing new school.
Thanks a lot for inviting. Hope it was useful to the listener.
I guarantee it is.